All right, today we're going to talk about mass-to-mass stoichiometry. Mass-to-mass stoichiometry is used to convert from mass of one substance to the mass of another substance chemical reaction. Now, a key thing here is the mass must be in grams. Okay, if it's in kilograms, you need to convert. Okay, the middle of this flowchart I asked you to do on the whole page. The middle of this flowchart is what we did yesterday with the moles known to moles unknown. To get to moles known and moles unknown, we multiply by the mole ratio. Okay, so the middle is what we've done. Independently, without putting it all together, we've also done mass known to moles known. I asked you to convert 27 grams of ammonia to moles of ammonia, then you would put 27 grams of NH3 over 1, and then you multiply by 1 mole over 17.0306, which is the molar mass of ammonia. So we've done that. Okay, we've also, on the other end, gone from moles unknown to mass, moles to mass. When we go moles to mass, any conversion, we take what we know, we put it over 1. After we take what we know, put it over 1. So if we have 3.5 moles of magnesium, we want to go to how many grams of magnesium that was. We put 3.50 grams mg over 1, and we multiply whatever was on the top, moles mg would go on the bottom. Okay, and we would multiply by the atomic mass 24.30153 of the magnesium. So we've done all that before. This is, we just have never put it all together. This was the chart I asked you to be on your whole separate paper. When we get back to school, you're going to have a quiz over this flow chart, okay? And I'll just miss out a couple of things, but you're really going to refer to this because today we're going mass to mass. Tomorrow we'll go mass to mass, but eventually we might just go mass known to moles unknown, or moles known to mass unknown. So we'll want to refer to this flow chart to where we are. So our first example that we're going to work is going to be the rusting of iron, represented as followed below. Oxygen reacts with iron to form iron 3 oxide. So to do any stoichiometry problem, we must have a balanced chemical equation. So our question here is, what mass of oxygen gas would be required to produce 16 grams of Fe2O3? So our known substance here. So once again, to do any stoichiometry problem, we need to have a balanced chemical equation. So our known information here is we have 16.0 grams of Fe2O3, and what we're looking for is the grams of oxygen. So this is mass to mass, okay? Mass to mass. So we're going to start in our first box, and we are going to go to our last box, mass known to mass unknown. So to do any stoichiometry problem, what we always know to do is we take what we know and put it, or any conversion problem, take what we know and we put it over 1. So we have 16.0 grams of Fe2O3. And so we're going to put that over 1, just like we do in any conversion. And so we are in the mass known box right now. So we want to go to the moles known box. So to go to the moles known box, we're going to multiply by a fraction. We're going to multiply by a fraction. The unit on top, grams Fe2O3, is going to go on the bottom of our fraction, because that is, and that, if we look at this, we look at our flow chart, it tells us that what goes on the bottom, to go from mass known, moles unknown, we multiply by 1 mole over the molar mass. Okay, 1 mole over the molar mass. So we'd find the molar mass of Fe2O3, 2 of iron times 3 oxygen. And when we do this, we get 159.688. Okay, we had to round that to significant figures. I think when we put in the calculator, we got 6882, but we needed to round that to significant figures. Now, grams Fe2O3 cancel out. We are now in the moles known box. Okay, so this is what we did the day before. Okay, to go from moles known to moles unknown, we multiply by the mole ratio. Mole Fe2O3 is on the top of our previous fraction. So it's going to go on the bottom of this fraction, okay? And then moles, my unknown is oxygen. So mole O2 is going to go on top of the next fraction. So finally, where we get these numbers from, this is the only time you'll have numbers in front of the moles in a stoichiometry problem. You get the 3 mole O2 from the balanced chemical equation. You get the 2 mole Fe2O3 from the balanced chemical equation. There's a 2 in front of that. So now moles Fe2O3 cancel out. And then I'm in the moles unknown box now, and I want to go from moles unknown to mass unknown. So I know that mole O2 is going to be on the bottom of this next fraction. So it's on the top of the previous fraction, so it's not canceled out. There's always a 1 in front of that. Okay, that is all. If you're ending in mass unknown, if you want to go to grams, you're always going to have 1 mole on the bottom of our last fraction. And then the molar mass of oxygen here, now 39.88, goes on the top. The molar mass of this goes on the top. Now moles O2 cancel, and I'm left with my problem now. So to solve this out, I would do 16.0 times 3 times 31.9988 divided by 159.688 divided by 2. Okay. So once again, you'd multiply all the top, and then you would divide all of the bottom. A couple notes I want to make about this is those ones that you see on this stoichiometry problem will always, in every single mass-to-mass stoichiometry problem, they will always be ones. Like the numbers, the non-1 numbers are what will change. So when I got this, I got 4.81. I need to round that to 3 significant figures. That's something I started with. And my last units there are grams O2. So 4.81 grams O2 is my problem. And just reiterating, these ones do not change. In every mass-to-mass stoichiometry problem, these ones do not change. So you would start filling this out, you could fill them out like that. All right, our next example, same chemical equation. It just asks what mass of iron would be required to react with 10.0 grams of oxygen gas. So once again, to do any stoichiometry problem, I must have a balanced chemical equation. My known information here is the oxygen. I have 10.0 grams of oxygen. So that's my known. My unknown is I want to know how much iron I have, how much Fe, and I'm asking for what mass. So that's question mark grams. So this tells me I'm going from mass known, because I have grams in that, so I know my mass. My unknown, my question mark, is also going to be in grams. And my unknown substance in this case is going to be iron. So my first step always to do is have a balanced chemical equation. Have a balanced chemical equation, and I do that, and I'm going to take what I know and put it over 1. Okay, so I know that I have 10.0 grams of O2, so I'm going to put that over 1. That's my first step in any conversion problem, is to take what I know and put it over 1. Now that is my mass known box. I want to go from mass known to moles known, so I'm going to multiply by a fraction. Grams O2 is going to be on the bottom of my fraction. The grams O2, and this would be the molar mass of oxygen, which would be 31.9988, which, it's the atomic mass of oxygen times 2. And now what's on the top? Now, when you're going from into moles known, you always have 1 mole of your known on the top. So 1 mole O2 goes on the top. So far, like I said, this is stuff we've done before. We've converted from mass known to moles known. We did this in the first or second quarter, and then again earlier this week. So now my grams O2 canceled, and I'm needing to go. I'm not to my mass unknown box yet. I'm in moles known. So to go from moles known to moles unknown, I multiply by the mole ratio. Once again, the mole ratio comes from the balanced chemical equation. So I know that mole O2 is on the top of my first fraction. So it's going to be on the bottom of this fraction. And I had 3 moles O2. I had 3 moles O2 because I got the 3 from the coefficient in front of oxygen in the balanced chemical equation. My unknown in this question, the thing that's the question mark, is the iron. So I have 4 moles Fe. Once again, I got the 4 from the balanced chemical equation. Moles O2 cancel. So I am now in the mole unknown box. I'm in the mole unknown box. That's not where I want to be. I want to be in mass. I want grams. So I'm multiplied by another fraction. Okay. The bottom of this fraction, once again, this is the last step. The last step is always going to, if you're going to mass, it's always going to have 1 mole of your unknown. So 1 mole Fe. 1 mole Fe, because remember, molar mass is defined as the number of grams per 1 mole. And then molar mass of Fe, we go on the top, 55.845. I'm not sure this is exactly what your periodic table has. I didn't bring one home with me. I'll make sure to go get one, but yeah, when I got that from the periodic table. So if your number's slightly different on that, that's not a big deal. So my moles Fe cancel, and now I'm ready to solve this out. My answer will be in grams Fe, which is what I wanted. Okay, so to solve this out, I would do 10.0 times 4 times 55.845 divided by 31.9988 divided by 3. Okay, so the top multiplied, the top all multiplied together, then divided by the bottom. And when I get this, I get 20, I need 3 significant figures, 10.0 is 3. So I get 23.3 grams Fe, because my grams Fe is what I was looking for from the problem, and it's the only thing that's not been canceled out in my equation. Reiterate there that our ones in the first, second, and fourth fraction are still 1. Okay, those will be 1 every single time. Those will be 1 every single time. Now our last example that we're going to work with this, we want to know what mass of water is required to react with 15.5 grams of nitrogen dioxide. Okay, what mass of water is required to react with 15.5 grams of nitrogen dioxide? Our unknown in this, our unknown in this is our water. It asks for what mass of water, and that question mark was pretty ugly. Let me fix that. So what mass of water? And my known, the information I was given was the 15.5 grams of nitrogen dioxide being NO2. So once again, this is a mass-to-mass problem, so we're going to have the same setup. We're going to have those 4 fractions there. I'm going to take what I know, and I'm going to put it over 1. I know that I have 15.5 grams NO2, and I'm going to put that over 1. I'm going to put that over 1 now. The point I need to make is that this equation is balanced. That's what I need to have. Anytime you're given coefficients, you can assume something is balanced. Okay. So to go from mass known to moles known, I'm going to multiply by 1 mole over the molar mass of NO2. So grams NO2, and that also works because grams NO2 is on the top of the first fraction, so it's going to go on the bottom of the second fraction. So to find the molar mass of NO2, I would do 14.0067 times 1 plus 15.9994 times 2. You get 46.055 grams NO2. That is the molar mass of nitrogen dioxide. On the top again, it's always going to be 1 mole. If you're going from mass to moles, you're always going to multiply by 1 mole over the molar mass. So 1 mole NO2. Right. So my grams NO2 cancel now. My grams NO2 cancel, and I am now in my moles known box because NO2 is my known substance, and then what I have there is moles. So my next step is the mole ratio step. I'm going to multiply by the mole ratio. So I know that mole NO2 is on the top of my previous fraction, so mole NO2 is going to be on the bottom of this fraction. And I got 3 moles from the balanced chemical equation. Now on the top of this one is 1 mole H2O. I made H2O. And it's a 1 because there's no coefficient in front of H2O, so it's understood to be 1. Now moles NO2 cancel. Moles NO2 cancel. And now in my mole unknown box, my unknown substance thing with a question mark is H2O, and I'm in moles. My last step, once again, going to be multiplied by the molar mass over 1 mole. This last fraction will always be a 1 mole of my unknown. It's 1 mole H2O, and then the molar mass of H2O, which will be on the top of this fraction, 18.0153. I can reiterate again, the first fraction, the second fraction, and the fourth fraction always have a 1 mole on it. The third fraction, the numbers in front of moles come from your balanced chemical equation. So moles H2O cancel out, and I'm ready to solve this problem out. So it would be 15.5 times 18.0153 divided by 46.055 divided by 3. Okay, so I multiplied all the top together, and I have divided by all of the bottom. I put this in my calculator, and I know I need 3 significant figures. So it is 2.02 grams H2O. Is grams H2O because that is what I have left in my fraction. So this is what your homework is today. If you have any questions, sorry about the first video. If you have any questions, please reach out to me, and I will do my best to assist you. Thank you.